Good morning. Thank you as well as a sponsor and someone who, well, both sponsor through CrowdStrike as well as sponsor personally of what Miguel, Lucas, and all the organizers have tried to do here at OffensiveCon. Thanks for coming. Thanks for giving this conference a chance. Those of you who it's your first time here, it's always a big deal to go to a newer security conference, both in terms of how's the content going to be, how's the behavior going to be, how's the location going to be. So I do think those of you who's your first time, you'll really enjoy it here. And thank you for coming up at such an early time in the morning to hear me speak. And I'm here to talk to you about this idea of reversing without reversing. And really what I mean by that is, when we look at reverse engineering, what does it mean? How do I think some people see it? And how do I think it should be seen instead? And how by seeing it that way, you might be able to accelerate some of the same work you're doing. I'm here to speak about this because I've been doing Windows low-level reverse engineering for about 17 years now. I actually had to go Google myself to figure out various years. And so I found out that on Planet Source Code, which is a really old, pre-GitHub way of sharing source code, I was doing articles around 2002, 2003, and getting awards about things like NTFS, alternate data streams, and calling native APIs from Visual Basic. I worked on something called React OS since 2003. Those of you who don't know, React OS is basically an open source reimplementation of Windows. It's basically like having Windows source code, except myself and many of the people have written it based on, some of us based on reversing, some of us based on testing, some of us just based on assuming how things are actually working. I also worked as a rent-a-coder. This was a website where people would bid for things they wanted someone to do. They would make requests, and then you would bid. So around 15 years old, I bid $25 to write an Outlook Express plugin. This was not something that was documented at the time. So I ended up injecting a DLL inside of Outlook Express and hooking a COM object, and then basically creating a toolbar there for a company that was called Spam Fighter, which is actually still around. So this was basically in 2001. $25 for about, DLL injector, COM hook, all that stuff. Now I got smart. This had a lot of bugs, and so then they put up a bid for fixing the bugs. And I charged $500 for that. So then I knew how to do business by then. I've always liked breaking things and also people. It's fun to poke buttons and push things around and see where things will go, what the OS will think, what the software will think, what the web service will think, what someone will think. And I've also just been really lucky. It sounds kind of cliche to say I've been lucky and blessed, but really I have. I interned at Apple with the 10-person team that built iOS. Not a lot of people are ever going to do that again and be in a team like that in a time like that. I joined CrowdStrike's launch team, 8 years ago, and I think we're doing pretty well, right? And I did a talk at a random university in Waterloo in Canada the same time while Margaret Sinovich was being acquired by sysinternals, and Dave Solomon was looking for a replacement and just randomly saw my talk on Slashdot. So I've always felt like I didn't really earn a lot of these things, and it's just been really luck. But as I've been doing this for all this time, I've given people the impression from what I hear that I'm always ready to drop 5 new pieces of research. Miguel and Lucas always tell a story where at OffensiveCon last year, like, hey, do you have an idea about what you want to talk about? And I give them a list of like 5 0 days and things like, which one of these do you want me to do this time? And they're like, okay, most people research a long time to find a topic. They don't have 5 topics that, I'm ready to talk about any time. 2018, patch after patch, bounty after bounty, travel the world in Windows internals, tweet Windows features months before Microsoft employees know they're there. I host an online source code tree where you can browse through the file directory structure and the file names of every file in the Windows source code. And so I've been told by Microsoft employees and others that they get emails like, can someone explain how Alex got source code and how I can get source code too? And they're like, he doesn't have source code. And people reply back, this is not possible. You cannot know these things without source code access. Clearly, he has source code access. Or Microsoft employees are saying, this person has source code access. How can we sue him? And people have to explain, no, he doesn't have source code access. So then, how is this possible? Well, the first thing is let's look at why there's reverse engineering, right? And maybe this is simplistic, but reversing is usually to understand how something works. Why does someone need to understand how some closed proprietary system works? Well, sometimes it's commercial reasons, right? To copy, right? In the hardware world, there's a lot of reversing of integrated circuits to copy things, right? And in biogenetics, pharma, there is a lot of commercial copying. To attack, to bypass the product, to understand its defenses, right? These are commercial, malicious, or sometimes legitimate in some countries' ways why you might want to do reverse engineering. Now, sometimes it's just for pure fun, sake of enjoyment. Like I personally just get a kick out of reverse engineering. I know many people do as well. And sometimes it's also for education. You either have to because it's your job, or you want to teach people how something works. You're doing a book on something or a training course. Or maybe it's part of your job, you're an Intel malware analyst and you have to reverse engineer the malware to write a report to teach people how it works, to make them understand kind of what's going on behind the scenes. And really, depending on the motivation and the goal, I think the process is a little bit different in terms of, how you're going to do reverse engineering. When I reverse engineer Windows, I need to understand down to the detail why something was done in the way it was done, not just how. If I just put in the Windows internals book or in a training class, there are 32 priorities. The very next thing someone's going to do is, Alex, why are there 32 priorities? It says 32 in the assembly code, man. Move EAX 32. That's why there's 32 priorities. Right? That's not going to be an answer that's going to be conducive to further discussion and further people taking training classes or reading a book. They want to know why were these decisions made. When you're doing other kinds of reverse engineering, you may not need to know why. It's like, okay, this is the IP address it talks to, done. Not why. Why that IP address? Well, I don't know. It's just the proxy server, right? So I need to sometimes dig down to details that people don't usually need to dig down to. Now, when you do reverse engineering, the traditional approach is you disassemble, if it's software, right? You disassemble or you decompile the thing. Use a tool like IDA or Ghidra or other tools on the binary. Now, when you're doing malware analysis, you don't have symbol files, usually, right? There's always some surprises. When you're reverse engineering Windows, you have symbol files, right? You have the public symbols that give you the names of the functions, and in many cases, even the data structure. So you're kind of cheating, right? A lot of malware analysts say, that's not real reversing. You have the data structure right there. I had to spend 5 months figuring it out. And that's true. In some ways, it is cheating, but is it not reverse engineering if to use additional tools beyond just assembly? Like, is decompiling assembly the only definition of reverse engineering? Well, that's why I'm kind of here to talk about. Now, if you're just disassembling and decompiling, you're not going to get the why. And of course, you're not going to get things like macro names, constant names, define names, source file names, line numbers, local variable numbers, right? You can stare at IDA and hex arrays all day. It's not going to give you that information with publicly available data. So of course, when someone comes in around and says, yeah, in min kernel /ntos/ke apc sub.c at line 417, the local variable there is called, people are like, you can't know that without source access, right? And the reality is most people also don't care about that level of information. They want to know, how do I inject the APC? Why do you care what source number it is? And reversing takes time. So when you come along and you're dropping source file names, a week after something gets released, people are like, how did you, in a week, figure out how this works and also figure out the source file name where it's in? Well, my very first trick was the Windows check builds. The Windows check builds up until Windows Vista, and I think I'm taking some responsibility for this, contained something called assertions. And assertions in the check builds, which many people didn't even know what a check build was, you needed basically an MSDM subscription or a school subscription to get these. Assert statements have lines of source in them. When you're asserting if foo equals false, you get in the binary the string foo equals false. So if the variable is a constant name, equals, I don't know, underscore max threads, you know that the constant is called max threads. You also know, what the variable name is. And the assertion also contained the file name, the line number, and the full path. So now you know exactly that at line 14C in this file name, in this path, there's a local variable with this name being compared with some macro value. And so when I worked on React OS, I thought it'd be really funny to just troll people by as much as possible using the assertions to make sure every React OS file name matched the Windows file name, every local variable matched local variable, because I was 15 years old and I thought that was really funny to troll people that way. Obviously, people were really upset, like, okay, so you're basically just begging to get sued at this point. Even though this is public strings, right, it makes it look like something shady is going on. Now, as of Vista, there are no more assertions like this. They're stripped from the binary, possibly because of this, possibly for other reasons. I can't be the only one who had figured this out. But then they made them annotations in PDBs. And if you obtain the PDBs from certain official locations, like the Windows Driver Kit, you still saw the strings in the PDBs, and then they eventually stopped doing that as well. So now, unless you have private access to things, you won't get these assertions, these strings anymore in most binaries. So that's kind of over. But that was one of the first things I'd figured out. And I still consider this reverse engineering. Figuring out that there's these strings and how to use them, to me, is part of the process. The second thing is a lot of people reverse by looking at the binary itself. And especially when you're looking at Windows, looking around the binary can be very helpful as well. For example, there's tools and utilities that often are used to troubleshoot a system or repair a system or service it. And I've seen this a lot from people more on the hardware side or the IoT side or even the car hacking side, where the way they actually got their start is they literally, I don't condone this, but they literally went into the garage and got the manual for like how the CAN bus on this car worked, and they just read the manual that's private to garagists only. The legality of that is, somewhere in the gray area, because you could become a garagist yourself and get access to it. Is there an NDA there? I'm not going to discuss legalities, but a lot of people in the hardware world are familiar with this. Well, and the same thing happens in a software world as well, except here they're actually fully legal. These are official Microsoft tools that Microsoft used to release, like the support tools, the resource kit, the SDK tools, the WDK tools. These are tools that analyze Windows behavior, and they'll often call Windows APIs. And they'll often have less stringent security around what they're leaking. There'll be lots of printf statements, perhaps with names of structures and fields of structures from the user side, right? They'll have names of macros. They'll even have source code in some cases. A good example, the best example probably is the Windows debugging tools, which comes with WinBag, which then has the KDX file, the kernel debugger extension files, which know how to print out various kernel data structures, including some that are not in public symbols, because if you look at these DLLs, you literally have printf statements printing out every offset, every field name, every type in a bunch of data structures. And many people, this might be obvious to you, which is great, but many people don't think, hey, let me reverse engineer the plugin for the debugger that knows how to dump the data structure to actually figure out what the data structure looks like. So you have to look outside of the binary sometimes, look around it, reverse other things than just, the kernel itself. Now, other than reversing things, people are often forgetting there's header files for a lot of things, right? In the Microsoft case, there's the SDK, WDK, there used to be the DDK, the IFS, all these kits that provide the officially documented public header files that show you various Windows prototypes. I've seen people at conference talks reverse engineer not MSDN documented, but header documented. They Googled for it. They didn't find a function name. They reversed it what the prototype looked like. If they had looked in the header files, it was right there. There's a lot of stuff that's in the headers that's not on MSDN. Sometimes by accident, sometimes on purpose. They just don't want to do the tech writing, but it is in the header files. Now, on top of that, sometimes there are header files that they accidentally open up. For example, in Windows 10, Threshold 1 and Threshold 2, WDK had the full set of min-win header files. These are the internal Microsoft headers that one beta build of the WDK had, which included all the system call prototypes and all the exported functions of the kernel and hundreds of data structures and comments, more importantly, around things that had never been seen by anyone. And so a lot of this is paying attention to what's getting released. Download every build, get every symbol, download every header file, build up a collection, because all it takes is one mistake. Right now I've got people emailing me every week, can I please get a copy of the header files? I'm like, they took them offline. I'm not going to give you my copy. I mean, I don't know the legality. It's a public thing at some point. After it's deleted, is it still public? I don't know. Get your own copy. It's not that I don't want to share, but clearly they made a mistake and they got rid of this. Or Singularity, which was a research operating system Microsoft worked on, public, which had integration with Hyper-V. So all of the Hyper-V header files are part of Singularity still today. You can go on Codeplex and download Singularity.zip, and you'll have some hypervisor header files. For example, Mathieu Schriech showed this, one of his presentations. So header leaks or public headers are also a way that I consider this reverse engineering, figuring out the right header file to look and the right build to get. To me, that's part of figuring how something works. And then there's other artifacts that may not even be where you think they are. Gabrielle, Viola, and I did a presentation of Black Hat on WDF. And WDF has these 64-bit encoded names. They're basically just hex. We had the name of every WDF state name, a giant comment describing what it is, and its security descriptor straight from an internal Microsoft header file that unless you're an employee, you don't get access to. Except there's this build process where they basically take that entire header file and stick it in the data section of some DLL, part of some kit. Again, it's public. If you dump strings on this DLL, you'll get like an internal header file inside of a DLL file. Sometimes there are official private symbols for some binaries, like OLE32, URLmon, Windows.UI.XAML. Microsoft produces private symbols for these to help people analyze them. But because they use precompiled headers, a lot of times structures that have nothing to do with COM, that have nothing to do with URLs, end up in these private symbols. For example, if you want to know the very latest 19H1 system information classes, they are in the private symbols of the COM DLL, because COM imports the same precompiled header as NTDLL, as some other DLLs, and you get information about the kernel by looking at COM. I know nothing about COM, but I use that PDB file all the time for that. And then there's presentations and blog posts about Microsoft employees, and I'll get talking about employees as well. Now, there's also leaked source code, right? So there have been various source code leaks. All of NT4 source repository leaked many, many years ago. The build system, the compilers, you can basically build NT4 from source. Parts of Windows 2000 have leaked. Xbox, the first Xbox, not the Xbox One, the first Xbox, its entire kernel and NVIDIA GPU driver leaked. The Windows Research kernel, which is Microsoft's Server 2003 kernel for academic purposes, it's on GitHub. As of today, you can go on GitHub, which is a Microsoft site, and look at the leaked source code of that. All of the Windows 10 anniversary update shared source kit, which contains the ARM64 bootloader, leaked on various forums. All of Windows CE 6.0 leaked. Now, I don't actually condone looking at leaked code. Me, myself, I've looked at a few of these things, and not for the stuff I do research on. And I'll touch on that at the end. I looked through the compiler of NT4 at some point because I thought it was historically interesting. I've never talked to anyone, and I'll never talk to anyone about information that I saw on the NT4 compiler source. Even though it's public, anyone can download this stuff. I looked at the Xbox GPU driver, for the Xbox from 15 years ago because I thought, hey, I've never seen a GPU driver before. I wonder what it looks like. I've never given a talk. I'll never talk to anyone about the Xbox GPU driver. Even though it's public information, I'm morally opposed personally to use this. But of course, other people can, right? Everyone has a different boundary. I've seen, Google Project Zero researchers reference in Google.com blog posts snippets of the Windows Research kernel. I was like, I'm pretty surprised Google's letting you basically paste leaked code. And they got back to me. Our lawyer said it's not IP theft if it's public. I'm like, okay, cool, all right. I don't do that. I don't judge people who do. It might even be legal to do it. but you need to understand there's a lot of information out there that is actually in leaked source code people can get. And then there's about 5,000 Microsoft Most Valuable Professionals, MVPs. They all have the ability to request source access to all of Windows, right? So I don't think they do illegal stuff with it. I don't think they share it incorrectly, but every MVP has access to that. Now, outside of these unofficial channels, there are channels for official source code. All the kits, the DDK, the SDK, WDK, they come with lots of legitimate, free-to-use source code. Most of the file system code is public. Entire driver stacks are public. Input stack, storage stack. All of this is on GitHub now. You don't even need to, official Microsoft GitHub. You don't even need to download the kits. All the driver samples are there. Microsoft Research had a gold mine of information before. They wrote Windows's TCP IPv6 stack, the combined stack. Now, a lot of rewrites happen because Microsoft Research doesn't publish the final builds, but you can learn a lot of Microsoft's the original Windows XP combined IP stack by looking at Microsoft Research code, for example. Singularity, as I mentioned, had lots of useful source code there. For example, the entire kernel debugging protocol, KD, it's in source code and Singularity. Some of the source code isn't where you'd expect. If you install the Windows debugging kit, WinBag, there is in there the source code for the network kernel debugging and USB driver. And I mentioned this actually at CanSec West in a talk last year. Then there's what we call private symbols. Now, private symbols are normally accessible only if you work at Microsoft. And private symbols actually contain all the data structures, all the file names, all the local variables. I mean, everything but comments, basically, are in private symbols. So if you have private symbols, it's almost as if you have source if you then combine it with something like hexarrays. Well, officially, by accident, so this wasn't like stolen or leaked information, Microsoft released the Vista kernel private symbols if you got a specific build of the beta of the Windows driver kit of Vista. And then I told them, hey, you made a mistake, and they removed it. They thanked me, but obviously I kept a copy because it was public information. It's just a PDB. The Windows 7 kernel 32, NTFS, kernel base, and NTOS kernel, so kernel private symbols, leaked in the recycle bin of the temporary directory of a Visual Studio 2012 trial ISO. I mean, sometimes it is just plain luck, people. And then sometimes public symbols for components that don't have any symbols make it in Windows symbol packages, which they don't produce anymore because of that. Now, of course, if you work for the government, if you work for certain large vendors, there are people that get private symbols no matter what in the community that work at various companies where they have access to this. And yes, private symbols really accelerate things. You know, when I was working on the Windows Internals 6th edition book, which covered Windows 7, of course, I used the private symbols for the Windows 7 kernel. It made it so much easier to understand what the code was doing, especially for writing a book that helps people around that, right? So sometimes the people make symbols make it out. Then there's the final element here, which is the human element, right? So there are blog posts, official condoned blog posts from Microsoft employees with various examples and snippets, especially debugging posts, and they have constants or function names or things that are not, they're not trying to hide them, but they're not typically public, but, they get allowed to publish that information in a blog post or forum post. They give presentations at Blue Hat, Build, WindHack, PDC back in the day, and they had legitimate, authorized slides where they'd have certain constants, certain values that are useful, if you're doing research. And they're okay with these being out there. They understand, okay, there's a snippet there. Academic research papers, and sometimes just shooting off an email, especially if you're not someone malicious, if you know that this is someone doing a training class to educate people or writing a book, or they're a white hat researcher, just ask an email, hey, I really don't understand how this function works. Why do APCs work this way? If you're not a complete DICK in the industry, you might have a Microsoft employee talk to their managers, hey, can I tell Alex about how this works? I mean, I don't think this is not a 0 day he's going to drop. No, I'm not saying please go email Microsoft employees, right? This is like a perk if you get respected in the community and you're a good person, which I like to think I am. But, sometimes it really is like, how did you find that? I was like, I just asked someone and they told me the answer, right? Now, of course, other actors, there's other ways to get information out of employees. I don't do that, but of course you have to understand in the world that we live in, there's other ways that this information can make it out. Now, once you have all this, then there's the question of accelerating and scaling, right? You have all these areas of reversing engineering. What do you do after that? Well, once you've been doing something long enough, you build a body of knowledge, right? And especially if you're downloading every build and getting every little small thing there is, the smaller iterations of work that you get, once you have the body of knowledge, the easier it is to keep updated. If you just look at Windows stuff every 3 years, and I know some of you, you look at Linux a little bit, you look at hardware, and then you go back to Windows, a lot of stuff has changed in 3 years, and you have to keep up with it, figure out where everything else is, what's new, what's changed. I've been part of the Windows beta program since pretty much I was 15. I used to get CDs by mail with new builds of Windows to the official beta program that I could then see the little differences every 3 months. Now there's a Windows Insider Preview, which is a game changer. You can see differences every week almost, right? And it's much easier to diff what changed in a week than what changed in 3 months, or what changed, from Windows Vista by Windows to Windows 7 by only looking at that. So diffing things, knowing what to diff, knowing when to diff, how to diff, so where you see that, how does you know that a week later? Because if you can diff within a week, and they added one function, it's easy to see that one function, right? Peter Banish, for example, he has a tool, he has an ntdiff.github now, which does exactly this, and it's so much easier. So to recap all this, you need to go beyond the binary, go beyond looking just at the disassembly. Assertions, extension DLLs, header files, PDBs that make it out when they shouldn't, leaks, depending on the legality around that, various tools, taking advantage of betas and whip builds, presentations, code snippets, employees information, right? To me, this is all reversing. This is all understanding how something works and accelerating that knowledge. Now, beyond that, there's also spending the time, right? Most people, the classical example of someone's day is 8 hours of sleep, 8 hours of work, 8 hours of other stuff, eating, family, fun. And really, if you think about your 8 hours of work, in most cases, you're spending an hour commuting back and forth, 2 hours if you're in some cities, 60 minutes of lunch. That's 3 hours if you're in France, of course. And among all that stuff, how much time do you actually spend doing work? I mean, probably 5, 6 hours. That's everyone, right? Imagine if you changed that. Imagine if you slept less. Imagine if you didn't eat lunch, if you didn't eat breakfast, if you spent less time with your family. I'm not saying these are healthy things you should pursue, but I'm saying if you make these sacrifices, then yeah, over 17 years, think of all of the hours of extra reversing, of extra work someone can get done if you're willing to do this. And, it's at the end of the day, you have to ask a tough question. Well, okay, clearly, Alex does this, and there's my wife's not happy about this. I came home after 4 weeks of training, and when my daughter was 2, I think she forgot who I was, right? And that was not a nice moment in my life, right? And some of that is making those sacrifices. The last thing I'll say is, reading other people's research, reading tweets, reading blog posts, and also reading books. There are old technical books out there that no one knows that information anymore except some Dell BIOS employee that's about to retire, and some book called Undocumented PC, published in 1984, and that explains some BIOS interrupt that's still used by Windows 10 today, and that still maybe has a vulnerability in there. So finding these really old books that explain kind of the foundations of the x86 and the BIOS, the stuff that we've been using for the last 40 years of computing, a lot of that is ancient knowledge that's dying away. When I read those books, and when I taught classes at Microsoft and I was 19 years old, I didn't want them to know I was 19, so I would say things like, remember, I wouldn't shave, I'd say things, remember when, back in the BIOS days, we had terminated and stay resident programs, TSRs, hooking interrupt 21. No, I didn't remember that. I was not around when those things were going on. So too many people these days I find, don't do this basic research of like, hey, what is the body of knowledge that already exists kind of around this? So if you will look for a formula, I'd say look outside the box. Don't just reverse code. Look at everything around the code. Be prepared to sacrifice and optimize your time and pay this cost, if you want to figure out how do you do this at a speed. And don't stop learning. The more you know, the more you accumulate, the more you can build on that. And the last thing I'll say is, yes, I have NDAs with Microsoft since day one. I do not talk about many things, and I will never talk about those things because I don't want to spend my days in jail, right? If I actually went up and talked about source code I was given access to, I would go to jail. I don't want to go to jail. I have a moral compass. There's things I know that I don't want to talk about. I don't want to share. I consider that information proprietary, even though it might be public. I personally don't like blogging about, leaked source code. My moral compass says I don't want to be that kind of person. And I'm also not a sociopath, at least I think I'm not. A lot of Microsoft employees are my friends. We go out, we dine together, our wives know each other's. I'm not trying to leak stuff. People who think, like, how does Alex leak source code? Like, why would someone do that if they're trying to, engage in a community and have a partnership and, don't want to be lonely and hated? So really, you can believe or not believe this, but think about it. Would someone really take these risks to talk about stuff they're not supposed to talk about? So it really is hard work, looking outside the box, and frankly, having done this for 17 years. And I believe firmly anyone else following these steps, this path, would look the same. And you think they have source code access maybe, but they don't. So anyway, thank you very, very much. I hope this wasn't too much self-aggrandizing or anything inappropriate, although it is an offensive con, right? So thank you and enjoy the conference. Or I don't know.
Mike? Yeah, okay. We got like 4 minutes of Q&A. Anybody got questions? Please give me a clear show of hands. Okay. It's too early. No, it's not.
Good morning.
Morning.
How do you deal with InfoSec burnout with such a busy schedule, so many hours put in working? I feel if I put 10 hours in sometimes, I get burned out quickly, and I was just wondering how you manage that.
I don't know if I have a solution to burnout because I literally feel burnout more and more. I have like a sign in front of me that says, don't burn out and don't give up right now that I'm looking at. So, I think part of it is taking a break from time. I travel a lot. I vacation a lot. There are weeks where I'm just with my wife and daughter and like Bora Bora. I went to Galapagos. I went to Patagonia and just kind of tuned out the world for a bit. That is starting to not work anymore. So I don't know how much longer I'm going to keep doing that, but yeah, I'd say you need some me time, and that's one way you can definitely help. Or just sometimes looking at other things. Like I've done Mac OS research. I've done hardware research just to kind of leave Windows a little bit alone. You might say, okay, so you went from like alcohol to drugs. That's still InfoSec, right? So yeah, travel the world, I guess.
More questions? So how many gigs of Microsoft released resources do you have?
Hundreds, petabytes.
And how do you index that?
Oh, that's the real question, right? All right. Thank you, everyone.
Thank you.